All right, so in this spell work here, all I'm asking you to do is to simplify the expression. So in this first one here, you can see I'm adding this parentheses to this one. So if you remember from the first semester, when we add things, we want to combine like terms. So basically things that have the same exponent. So these two x's both have x squared, which means that I can combine these two terms. And when I combine, I actually add the coefficients. So this 3 will be added to 1, which gives me 4, but they're both x squared, so I'm going to write an x squared next to it. Then I have x to the first power, so both of these are x to the first power, and this coefficient here is a 1, so I'm going to add it to this negative 4. 1 minus 4 is negative 3, and then I'll put an x besides it. The last term I have is the numbers. So I have a 1 and a 7. If I add them, I get 8. And so looking at these three terms, they're all different, right? This one's an x squared, this one's an x, and this is just a plain number. So now I can't combine anymore because, well, there are no more like terms. So this is my final answer, simplified. This next following one has a minus sign between these two parentheses. So we must always distribute that negative sign into the parentheses that's on the right side first before we try to combine like terms. So in this case here, this one does not have anything in front of the parentheses. So I'm going to bring this guy down as it is, because if it doesn't have anything in front, then those parentheses are redundant. So I'm just going to bring those numbers down as they are. Then this one here, I'm going to distribute the negative sign, which makes it a negative x squared, a positive 4x, and then a minus 7. Looking at this, it looks like you have two x squares. So if I combine those two, I get, well, 3 minus 1 gives me 2x squared. And then I have an x here and an x here. If I combine those, I get a positive 5x. And then the last term here, I have a 1 and a negative 7. So if I add those, I get a negative 6. And it looks like I can no longer simplify, so this is my final answer. Then for this one here, it looks like I'm multiplying this parentheses with this parentheses. So when I do something like this and it's multiplication, I have to distribute. This type of distributing is called foiling. So foiling says I need to multiply the first term with the first term. So 3x times x. Let's think about it. That's a 3. The number in front of this x is a 1. So 3 times 1 is a 3. Now, x times x is x squared. The reason why is because the number of this exponent is a 1 and this exponent is a 1. When you multiply two things that have the same base, you add the exponent. So 1 plus 1 gives me 2. Then I'm going to multiply 3x with 7. So 3 times 7 gives me 21, positive 21. But there's an x here, so I need to drop an x down. All right, so now I'm done multiplying with the 3x because I've multiplied to both terms on the other side. So now I'm going to jump to multiplying by 1. So 1 times x is just 1x. 1 times 7 is 7. So looking at this, it looks like the middle terms are the only two terms that are the same like terms, right? So this is x, this is an x. If I combine 21 and 1, I get 22x. And then the other two numbers, it looks like these numbers here don't have anything to combine with, so they just drop down as they are. So this is a 3x squared and a 7x. And so then this is my final answer because I can't combine any more terms together. All right, I wanted to review these three problems with you guys because these skills are very important and will translate into the problems that we're going to be doing in second semester. So I'm going to show you a few notations that might feel new, but they're very much intuitive to what we've already learned. All right, so today I'm going to show you operations with functions and their notation. So operation just means like different ways you use a function. So addition, subtraction, multiplication, and division. So we've all talked about these operators before. And then in this case, in these notations, you're going to see f and g, right? So in this case, f is some sort of function, and g is some sort of function. You will always be given what f is and what g is for these problems that we're going to see. Now, in this case, anytime you see in the parentheses f plus g, all that means is you're taking f and you're adding it with g. When you see f minus g, that's all you're doing is taking the function and subtracting it with the other function. And then multiplication is this one. So anytime you see this symbol, you're multiplying the two functions together. And then division is when you divide the two functions. Now, we're not going to do a lot of division problems in this chapter, but we will see it again in later chapters on how you could divide functions. All right, so you can see here I've given you this example where you have the function f and the function g. And in the first part here, it's going to ask you to add f with g. So anytime you see this symbol, that is saying, well, I'm going to grab f. Let me do f in green. So here's f, and here's g, and I'm going to do that one in pink. So it's saying that, well, I have to add f's equation, so that's 3x squared minus 2. I'm going to take this equation and I'm going to add it to the other equation. And I'm going to put them in parentheses so you can see them separated from each other. So again, this one's function f and this one's function g. I'm going to add those two equations together. And if you look at this problem and ignore this, you can see that all I have to do is combine like terms to simplify, right? So here's the thing. These notations help you figure out like what do you need to do in the problem. So this one's just saying to add, so I have to set up the equation given the function already. So if I'm combining like terms here, just like the bell work, these two combine to give me, well, that's a 3, that's a 1, so that's 4x squared. Then I can add, well, oh, actually, 5x doesn't have a buddy to add with, so I'm going to bring that down as it is, so 5x. And then the 2's are both, so this negative 2 is a constant, this negative 6 is a constant as well. So if I add negative 2 with negative 6, I get negative 8. And looking at these three terms, they're all different. So this is my final answer. So in the next one here, it says f minus g. So I have to write f first, which is, again, 3x squared minus 2. And then now I'm going to subtract it with g, which is x squared plus 5x minus 6. So this time I'm subtracting. Here's the thing. With subtraction, you do need a set of parentheses, at least for the second function that you write down. Here's why. If you forget to write parentheses around this, you might forget to distribute this negative sign to every term inside the function. So it's really important to use parentheses when in doubt, okay? It never hurts to use parentheses. As you can see here, this one doesn't need parentheses because there's nothing in front to multiply. So I'm just going to bring this function down as it is. But this one did need parentheses, so I remember to distribute that negative sign, which I'm going to do now. So I've distributed this negative to every term inside. And so here it is here. And now I'm just going to combine like terms like I was doing before. So I have a 3x squared here. Looks like a negative 1x here. So if I combine those two, that makes 3 minus 1, which is 2x squared. And then it looks like I have a negative 5x, so I'll just bring that down as it is, negative 5x. And then I have those two constants that I'll add. So negative 2 plus 6 gives me a positive 4 here. And so looks like this is my final answer because there's no more like terms. So that's my answer here. The next one here says f times f, right? That dot represents multiplication. So in this case, there are no g's that I need to use. I'm using f twice. So I'm going to write f down here. So f is a 3x squared minus 2. And then I'm going to write the multiplication sign. I don't have to in this case because there's parentheses. But then I have to rewrite f again. So this is f times f. And so I put some parentheses here because I can see that I'm going to have to be distributing, right? So it's really important to use parentheses, especially when you're multiplying. So I'm going to distribute the first term with the first. So 3 times 3 gives me 9. How about I do this in blue? And then x times x squared. So x squared times x squared. You have to add the two exponents. So this is going to be x to the 4th power, since 2 plus 2 gives me 4. Now I'm going to multiply this 3x squared with negative 2. So negative 2 times 3 gives me negative 6. And then I'll put in the x squared down here. And then I have to multiply with the negative 2 in the second term. So negative 2 times 3x squared gives me negative 6x squared. Negative 2 times negative 2 gives me positive 4. So looking at this, it looks like the middle terms are the only like terms here. So for my final answer, I have 9x to the 4th, because that just drops down. There's nothing to add it with. Negative 6 minus 6 gives me negative 12x to the 2nd power. And then I'll bring that down bring down the 4 here, since there's nothing to add it with. And so this is it. This is my final answer because there's no more terms to add with. So hopefully this gives you a better idea how we use these notations given two functions here. So what we're doing is just setting it up and then simplifying. So we're going to now turn to homework packet page 1. So I want you guys to do page 1, some of the problems on there. I'm going to do 3 of the problems with you guys, and then I would like you to finish the rest of the problem on your own. So hopefully these 3 problems will help you get an idea of how to do the other problems. All right, so in this problem here, this is page 1 again on packet 9. So they give us the 2 functions. How about I go ahead and color code them? So this one is my f function, this one's my green function. And you can see in part 1, or problem number 1, it wants me to take f and add it to g. So since I'm adding here, I want to grab my function f. So f is x minus 2. And I'm just going to use parentheses here to be safe. I don't have to with addition, but better safe than sorry. And then I'm going to take the other function g, which is 2x minus 7. And then I'm going to go ahead and add these two. So just combine like terms. So if I take this x and add it with this x, since they're both x to the 1st power, this x has a 1 in front, and that's a 2, so this is going to be 3x. And then negative 2 plus negative 7 gives me negative 9. And so looking at this here, I can't simplify any further, so this is my final answer. So in this case, I didn't need those parentheses because there's nothing in front to distribute, so I could have just go ahead and combined the coefficients, the like terms. And this is it. So now let's try a tougher problem. Let's do number 6, and then we'll do 7. All right, so in this problem here, we have our function f and our function g. So with number 6 here, I am taking f and I'm subtracting it with g. So let's set that up here. So f is negative x squared plus 6, and I need to subtract that with g, which is 2x squared plus 3x minus 5. And so looking at this, I am subtracting, so I need to distribute that negative sign first. And I'm going to distribute to every term in the second parentheses here, or into g. So again, this first one here doesn't have any number in front to distribute, so I'm going to bring this parentheses down as it is without the parentheses. And then I'm going to distribute the negative sign. So I've basically switched all the signs here. And then from here, I'm just going to combine like terms. Like these are both x squared, so if I combine them, that's like a negative 1 minus 2. So that's going to be a negative 3x squared. And then I can see I have a negative 3x, so I'm going to bring that down as it is because there's nothing to add it with. And then finally, I have a 6 and a 5, which I can add to get 11. So looking at these 3 terms, they're all different exponents, so this is my final answer. Now this last one here, I'm multiplying f with g. So this might take up a little bit room just because I noticed g has 3 terms and I'm going to be multiplying. So first I'm going to grab my f since that comes first. So that's negative x squared plus 6. I'm going to wrap that in parentheses. And then I'm multiplying with g, so that's 2x squared plus 3x minus 5. You can see with this one here, I'm going to be distributing this first term to 3 terms this time. So let's go ahead and do that. So negative 1x squared times 2x squared, well, negative 1 times 2 gives me negative 2. X squared times x squared, you're going to be adding those exponents. So that's going to be x to the 4th power. Then I'm going to be taking negative x squared and multiplying it with 3x. So that negative 1 times 3 gives me negative 3. And then this x is squared, but this x is to the 1st power. So when I multiply the x's, I add them. So 2 plus 1, this is going to be a 3. Negative 1x squared times negative 5 is going to make a positive number. And then I have a 5 because 1 times 5 is 5. And then x squared goes here. And then I still need to multiply my other number. So 6 times 2x squared gives me 12x squared. 6 times 3x is going to give me 18x. And then 6 times negative 5 gives me negative 30. So looking at this, you will start to notice that these terms are all different except for the x squares. So because these two are the same, I can combine them, but I'll bring everything else down since it doesn't have a buddy to add with. So I have a negative 2x to the 4th, negative 3x to the 3rd. I'm going to add 5 with 12 to get 17x squared plus 18x minus 30. And so this here is the most simplified answer because all the exponents are different, so I can't no longer combine. All right, guys, I hope this helps you with the homework packet. Until next time. Bye, guys.